Prime Minister Narendra Modi and his Spanish counterpart Pedro Sanchez have jointly inaugurated the Tata-Airbus aircraft complex for manufacturing the C-295 aircraft in Vadodara. This is a major Make in India milestone, opening a new chapter for India's defence and space industry. The facility is the first private sector final assembly line for military aircrafts in India, and the rollout of indigenous planes is projected to take place sometime around September 2026. The C-295 plant is undoubtedly a game changer. However, there is one last mile we need to cross to achieve 360-degree Atmanirbharta in defence. And this is perhaps the most crucial one. There are four key components of military aircrafts: the fuselage, the avionics, weapons, systems and the engine. While India has the capacity as far as the first three components are concerned, we don't have the capability to manufacture a jet engine. Jawaharlal Nehru had foreseen India's desperate need for a homemade fighter jet as far back as in the early 1950s. He went so far as to bring in a team of combat plane designers from Germany. The team was led by the legendary engineer Kurt Tank, who had designed Focke-Wulf FW-190. This was one of the most successful Luftwaffe fighter jets in the Second World War. The plane he designed for the Indian Air Force, the HF-24 Marut, is the only Indian-made combat plane to become operational. Yet, although with patchy results, with underpowered engines, Marut could not match the MiG-21s. It was not on the Indian Air Force's air-to-air fighter list. The Marut was only limited to light ground attack duties. It could carry 1,800 kilograms of bombs, 100 rockets, as well as four 30mm cannons. Unfortunately, its design was too rickety to fire all four cannons together. Maruts came to the limelight when they were used in the Bangladesh Liberation War in 1971, especially in the desert sector. These also played a role in the storied Battle of Longewala. It's been decades since we first set out to develop our own jet engines, with the C-295 plant becoming operational. Are we a step closer to realizing this dream is the big question. Joining us live at this point is Air Vice Marshal P.K. Srivastava, aviation expert. We also have Group Captain U.K. Devnath, former Indian Air Force officer, live with us. U.K. Bose, former CEO Sahara Airlines, is also joining us live. Let me make a start with you first, Air Vice Marshal Srivastava. What do you make of this big development today for India, this new facility that has, of course, been inaugurated by our Prime Minister?
So, Uday, I have been associated with this effort right from the beginning when the RFP stage was there. And then it got into another, I would say, cloud, which was single vendor. It became, and there a lot of confusion on that. I'm very happy to see today's scenes, because I see that, yes, now Prime Minister is going around and things are happening and the plant is operational. Of course, first 16 aircraft would come directly from Airbus in flyaway condition, and rest would be assembled, what we call final assembly level kind of thing will happen in India. And the plant has been made, and it's a great beginning. If you just trace the history of all the countries which have done, like later on, like let's take the China, our neighbor, they have gone through this route. They use their might of purchasing power to actually tackle this issue of manufacturing aircraft. The most important thing, which I would say is really significant at this point, is that this is happening in private sector. We always said, even from Indian Air Force, that unless both the arms of the nation are made to work for this very critical weapon system, it won't happen. Public sector, the HAL was doing it, but there was no private sector involvement for final assembly level or for manufacturing aircraft. It's a great beginning, and it's a very significant day for India. The Prime Minister has also recognized it. Spanish Prime Minister is also here, and they make a great sight. I hope this will give rise to the ecosystem which we have always been talking about, the defense industrial or the defense aerospace industrial base, which is the key component for any country to really manufacture aircraft. Over to you.
Okay, let me quickly, in fact, also rope in Group Captain Devnath. Group Captain Devnath, this is, of course, a big development, of course, a big stride for our indigenous defense sector. But what about manufacturing of engines, sir? When can we expect that to happen as well? That's something that's still missing from our capabilities, isn't it, indigenously?
Oh, yes, Uday, India has made great strides as far as an indigenous jet engine is concerned. Only thing is, we are one comma, or rather one small full stop behind the deadline. Kaveri engine has been developed by GTRE, Gas Turbine Research establishment, and they have done a wonderful job. Only thing is that it is a little heavy right now and it is a little underpowered. Indian Air Force wanted, HAL also wanted a fighter engine which should be able to generate about 95 kiloton plus thrust, whereas Kaveri is generating about 80 to 85 kiloton thrust right now. Similarly, it is overweight by just about 800 kg right now, which will reduce its performance when the airframe is matched with the engine. HAL has promised, and I think GTRE will do it. We are taking help from our well-wishers in Airbus industries, aerospace industries. GE of USA also is trying to chip in its bit. When India gets the technology, transfer of technology for F404 engine, and in future when we get our TOT for F414 engine for Tejas Mark 1A and Tejas Mark 2, a part of that TOT, USA has already agreed that part of that TOT will be added to Kaveri engine, and probably it will help us in reducing the weight by about 400 kg or 800 kg engine weight, and the thrust will go up by another 10 kilonewton. So we are very close, Ujay. Believe me, probably the first fighter aircraft which will be powered by a Kaveri or a totally made in India engine is just about 10 years away. Yes, Uday?
Absolutely. UK Bose, as far as our Indian aviation, indigenous defense program is concerned, how many strides have been made in the right direction, and what is the, hope for the future? UK Bose, can you hear me? Okay, I think we're having some technical trouble there with him once again. All right, let me get it back in Air Vice Marshal Srivastav. Air Vice Marshal Srivastav, no doubt our indigenous defense program is going great guns, and we've made extremely important strides in the last few years in particular, but also before that. However, of course, there is a lot of potential still for the future. What must we do to realize that potential?
Uday, when you talk about jet engine manufacturing, it's a very interesting question as to what we should do. Some parts of it has been told by Group Captain Devnath, but let me just give my own practical experience. The problem is in basically the kind of materials you have to have in possession to make the jet aero engine, and the kind of equipment you need, because the precision which is required here is of nanometers and micrometers, and they are very important because all these things are at very high temperature and very high speed. We have still not got the hang of it, and we don't have any ecosystem for it. I'll give the example of Shakti engine, which we make in HAL. Shakti engine, most of the parts are imported from saffron. So if you really see, the indigenous content is very limited. Let's be honest with ourselves. So what happens when I got an opportunity to make some hot engine parts of an aero engine, of the type of, let's say, M88 or something like that, I saw the commercial thing does not just work out. They were asking me to invest 100 crores, while over 7 years, I was being offered an order of 7 crores. How does it work? So the most important thing here is, will government support initially? It can only be taken by the government. Government spends on it, and the capital is a very capital intensive, production facility, and the kind of orders which will come initially very, very low. Therefore, you see, there are not as many engine manufacturers as you would like to have, and it's not something where people can compete. It's not something where orders will flow in and you can manage based on the orders. So your R&D, your establishment, your other facilities, tools, test equipment, and the kind of manufacturing techniques you'll need. You'll need to be having additive manufacturing. You need to be having all kind of laser machining. You need to be having all kinds of CNC machines, which are very, very precise. So when you add all this up, we are some distance away from really making a totally indigenous aero engine. Or you're now talking about the jet engine, which is of the fighter class. where we can launch our next generation of fighters like AMCA or our Tejas Mark II or something like that. We'll need to travel that distance. As a nation, we should realize that this is a strategic requirement, and aero engine manufacturing would fall in the category of strategic asset for a nation. And as long as we understand that and we use the might of our purchasing power, like you see, Indigo has given around 1,000 odd aircrafts order. We haven't got anything. Chinese, they use their orders, giving potential to establish facilities within their own country. So that has to be done. And you'll be shocked to know, if you want to trace history, Russians, they are very good at aero engine manufacturing. But the first one in 1940s, what they did? They actually reverse engineered the German aircraft which they caught. See, Germans and British were the first ones to launch get into this kind of business. And they caught hold of that, they reverse engineers, and they moved on. So we will need some technology transfer support, as Grupi Devnath has already pointed out. It'll happen. And it's happening now. The good thing is that it's happening, and in high quarters, people have realized that technology transfer or partnering with, other partners who are in, at whether they are at final assembly level or at, let's say, the next level, what we call, where the components are assembled or manufacturing the components. If that we learn by partnering with our international partners, get the technology, get the things going, establish the ecosystem, I guess we can do it. But we are very close to it. We are some distance away. We have optimism, but this optimism is to be filled up with all the efforts we need to do. Over to you.
Absolutely. Let me also, in fact, quickly join now Group Captain V.N. Jha, former Indian Air Force officer, who's also joined us now live. Group Captain Jha, how big a development, of course, will this initiative be for our Make in India Defence program, this innovative hub inaugurated today? But also, more importantly, Group Captain Jha, how much longer before we can finally be developing our own fighter jet engine? The engine manufacturing is something we still need to do indigenously.
This is the Achilles heel that we have been having, and I, being in the DRDO for reasonably a good time, I know GTRA has struggled, and what just now AVM Srivastava was touching upon, Russians were lucky to have reverse engineered the type of machines or equipment or component what Germans had, but it is not always easy. Our Kaveri engine, was very good. It was extremely good, barring that the total thrust that it generated, and that is the place where in the fighter aircraft, it is the single engine aircraft, even slight drop in the thrust can mark the doom for the flight, both flight safety as well as the performance. Now I believe when Modi government came, he had coordinated with the GTRE, because he was made aware that we have not been able to make any fighter jet engine. So various expert agencies around the world were contacted, and very few came forward to sort out the problems what we had. But the bottom line is that we couldn't progress on that. Kaveri engine was designed and developed. It was made, tested for reasonably long periods, thousands of hours at a time. But the thrust was the part where we could not cope up with the IF requirement because it was a single engine aircraft. And that is where comes the innovative minds. If your single engine is giving you the thrust of the type that Kaveri engine had, could we quickly have got into a platform where the dual engine fighter aircraft could have been produced? You can name it anything, Tejas or some other aircraft. Dual engine aircraft of that caliber, it's a small engine. It's a very small engine, and it can very well be accommodated into another fighter aircraft or a newly designed fighter aircraft into the belly of that with the performance which could be, par excellence with our own technology. Remember, whenever we have our own technology, you can play a plenty, you have room to play with. In 2013, 2012, 2013, when even I was working with some of the systems of LCA, when we knew that that time UPA government had shut down this program, our shoulders had drooped. All of us, we are feeling that what is the wrong with the LCA aircraft, because it had achieved everything only because there were some RFA of 1,000 odd plus which was to be done addressed. That is not a reason to shut down the program, because that is where Modi government should be complimented, because he then gave a push. Can you do it? He just asked ADA and HAL, can you do it? They said, yes, we can do it within a very short frame of time. He said, go ahead. And the result we see here today. Today, our LCA, even Mark 1, it has got some limitations. But even Mark 1 is almost nearly 4.5 generation aircraft. And with the avionics being refined, being augmented, being given performance enhancement, it can play wonder. And that is where I was coming back to the engine. If Kaveri engine was given that sort of maneuverability of a dual engine fighter aircraft, you can name it any other aircraft, our own engine would have been there, and you would have taken off from there, and the experience gained from there adds up in the design. Because what you are flying today was designed nearly many years back, and what input comes to us from the every sortie of LCA. It is a great design booster or the performance booster for the people on the ground who are still on the drawing board. So that is where we slightly missed out. But then there were a couple of problems. I believe, as Srivastav was telling you, I believe it is going to happen in the coming time. It may not be 10 years. I cannot give you the inside picture of what is happening with GTRE. It may not be 10 years, but then surely another replacement for 404, what is in the LCA, should be coming out in a couple of years not couple of years, maybe a few years of time. And that should boost our fighter aircraft generation. LCA is only the beginning. AMCA is the another one which is going on there. LCA Mark 2 is Mark 1A is already.
We've covered avionics, we've covered fuselage, we've covered weapon systems. When do we cover the engine leap, Air Vice Marshal Srivastav? How long will it take? Air Vice Marshal Srivastav?
You are muted.
Okay, we can hear you now. Yes, now you're there. Now we can hear. Yes.
Can you hear me?
Yes.
Yeah, so it's a very interesting question to ask. What is the timeline? Timeline, I would say, is accelerating. That is point number one. And point number two, that we got a lot of pieces of the jigsaw puzzle in place. That is there. And point number three, that the highest level of the government and the, I would say, political outfit, even the Prime Minister is seized with this issue. That yes, it is one of the problems which we need to resolve, because when we talk of aero engine and its technologies, we are not talking of something very small. Actually, aero engine technology represents all and sundry of the threshold technologies. You can even use AI in many parts of the aero engine functioning and its operations and the way we handle it. So if you really take it, the day we get hang of aero engine manufacturing technology and its R&D, we are really on top of the world. And you see all the manufacturers which are there, GE, whether you call it Pratt & Whitney, you could take Safran, or you take United Engineering Corporation in Russia, all of them are very developed and highly militarized or highly successful in military equipment countries. So this, we must accept that this is a national endeavor, and this national endeavor must be taken, with a stride which is needed. So coming to the final question, how many years I assess they'll take? I say if the momentum continues, I definitely feel that we'll have either the Kaveri engine rectified, modified, because I understand that thrust to weight ratio is a very critical issue. Normally it falls in the domain of 9:1 to 11:1, which is for the product 30 of United Engineering Corporation, which is going to Su-57. But we are not there, we can reach there. And it's an issue which is to be solved with the help of material, with the help of hot engine parts, with the help of the kind of speeds and thrust we can generate, and we can keep this engine small and put more missiles and more firepower in the aircraft. So if you take all of that into account, I would give myself that before the end of this regime or this tenure of Prime Minister Modi is going to happen. You'll find it happening before that, and something will come out which is successful, because there's a lot of thrust on it. There's a lot of policy initiatives which have been done, and there's a convergence of national talent around it. And when that happens in India, things happen.
What is the future of this sector looking like, Group Captain Devnath?
Uday, as far as India is concerned, this sector is very promising. To start with, let me assure you that CCS has been promised by DRDO and by ADA that Kaveri Mark 2.0 with all the requisite parameters required by Indian Air Force and HAL will be placed, will be ready by 2034, just 10 years ahead. The hot zone problems have been solved. The micro machining and late problems have been solved, because USA has given us late CNC machines which can do job with a precision of 6 sigma, that is 1:1 million part machining work. The hot zone problem has been solved. We have developed within India fiber material which can withstand 1700 degree temperature. And most important, the dynamic imbalance or dynamic balancing problem has been solved on computer. The test bench also has successfully ran with the dynamic imbalance problem solved. So Uday, give or take another 9 years, 10 years, and we are done.
All right, let me quickly get in UK Bose now, if he's able to hear me finally on the broadcast. UK Bose, if you're back with us, as far as you're concerned, when do we begin to manufacture our own engines, and how important is this component for our indigenous program?
The engine is the most important component, without which nothing will happen. So if that happens, that is the first thing which we must try, and then the other parts come in. Engine is the ultimate thing. If we can do that, that will be a big achievement for the country. And we must praise Modi government for it.
When you were, in charge of course, the Sahara Airlines, where did you source your engines from?
No, we had CFM engine, Pratt & Whitney engine in the beginning. After that, CFM engine, which is French manufactured. So these are the companies. They are the large companies.
Absolutely. All right, let's leave it at that. My thanks to all of our guests for joining us on this discussion.
For more such videos, subscribe to the NewsX YouTube channel, hit the bell icon.